Hello everybody, today I wanted to go over calculus and specifically derivatives, and I wanted to go over the typical derivatives that you'll see, and in another video I'm going to show you how I derived how to get the derivatives. So the derivative of a constant is going to be 0, the derivative of x is 1, the derivative of ax, and a is just a constant or a value, so a derivative of ax is just going to be a. That makes sense. It's a times the x, and we know the derivative of x is 1. The derivative of x squared is 2x, and the way it works for these guys is it's x raised to the 2 power. You bring the power down and you multiply the x by the power, so it just becomes 2x. Ax squared equals a times the derivative of x squared, which is just 2x. Square root of x is the same thing as x raised to the 1/2. Bring the 1/2 down, and you're left with x raised to the negative 1/2. So that's what I did here, x raised to the negative 1/2. 1 over 2 square root of x, it's the same thing as 1/2 x raised to the negative 1/2 power. Probably the easiest derivative is exponentials, specifically e raised to the x. The derivative of e to the x is also e to the x. The derivative of a to the x, though, is the natural log of a times a to the x. The derivative of the natural logs, we're talking about logarithmic functions now, the derivative of logs. The derivative of natural log of x is just 1 over x. The derivative of log of a equals 1 over x times the natural log of a. And then lastly, I wanted to go over trigonometric functions and their derivatives. So the derivative of sine theta is cosine theta, and the derivative of cosine theta is negative sine theta. Lastly, the derivative of tan theta is secant squared theta. I'm going to be going over in another lecture the ways or the mechanisms to solve for these derivatives, and there'll be quotient rule, product rule, sum rule, all these different rules to sort of find the derivatives for functions. Thank you.